Okay, in this video, I'm going to discuss some examples that illustrates implicit differentiation. Again, if you watch the first video I uploaded in I study, it was emphasized there that the difference between explicit function and implicit function, or expressions which are called as implicit and explicit. The difference is when y is expressed in terms of x, that's explicit. Implicit is when y is not expressed in terms of x, just like this example. Now, how do we use implicit differentiation to find for dy dx? The first step, of course, is to indicate the operator, the dx, on both sides. Okay. Now, following the rule for differentiation, the derivative of the sum is the sum of the derivative, so this can be written as 9x squared, derivative of 9x squared plus the derivative of y squared equals the derivative of 1. Okay, and then you know how to find for the derivative of this, right? This is 18x with respect to x, okay, plus the derivative of y squared with respect to x. So this part of the expression, if you find the derivative of this one, remember that you are computing for the derivative of y squared with respect to x. If it is derivative of x with respect to x, then it would be easy, but for this one, we're going to use chain rule, because y is actually your f of x, no? In other words, y squared is equal to f of x quantity squared, for which the derivative of this, okay, if you find the derivative of this, so the derivative of y squared, the derivative of f of x quantity squared, using the chain rule, this is 2 times f of x raised to 2 minus 1, right? 2 minus 1 times, you find the derivative of the argument for the whole function, or the inside. Okay, so following that, the derivative of y squared, if y is equal to f of x, is actually equal to 2y to the 2 minus 1, which is 2y, times the derivative of f of x, which is y, or you can just write this as 2y dy dx. So this is the difference between finding the derivative of a function with respect to x, or 9x squared with respect to x, and the derivative of y squared with respect to x. Because you notice you have this, you have to multiply, no? Upon finding the derivative, you have to multiply at the end by dy dx. So the derivative of this is 2y, the normal computation of the derivative, but you have to multiply that by the derivative of your y, okay, which is dy dx. And of course, the derivative of 1 is 0. Then, if it is possible to solve for dy dx, then you do that. Anyway, that's our objective, to find for y prime or dy dx. And by the way, another notation for dy dx is y prime, so you can also use that one. Okay. So solving for dy dx, you have 2y dy dx equals minus 18x, and that means that dy dx is minus 18x over 2y and dy dx is equal to minus 9x over y. So this is the dy dx, okay, using implicit differentiation of this expression. Let's consider now example number 2. Okay, this time we're going to discuss the derivative of 2x squared plus x plus xy equals 1. Okay, how do you find the derivative of this? First step is to indicate the differential operator, no, on both sides of the expression. Okay, and derivative of the sum is the sum of the derivative, so that's derivative with respect to x of 2x squared plus derivative of x plus the derivative of xy equal to 0. Okay, and what is the derivative of this? Of course, this is 4x plus this one is 1 plus, now you have here the derivative with respect to x of xy. What are we going to do here? Take note that y is a function of x. Then you have another function here, no? If you recall, there is a differentiation rule that says the derivative of the product of two functions is equal to the first times the derivative of the second plus the second times the derivative of the first. So we're going to apply that here. So that means that we'll have x being the derivative of the first times the derivative of y. Now, what is the derivative of y? Okay, we have seen from this expression, no, in our previous example. We have seen that the derivative of y with respect to x is actually dy dx. Okay, so that means that the derivative of y, okay, the first times the derivative of y with respect to x is your dy dx plus the second times the derivative of x with respect to x. Then this is equal to 0. Simplifying, we have 4x plus 1 plus x dy dx plus y times what is the derivative of x with respect to x? That's equal to 1. Okay, so we are left with y here, and then you have 0. And then after that, be sure to solve for dy dx. Okay, so how? Manipulating the equation, you have x dy dx. The rest will be placed on the other side. Okay, but we do that by subtracting both sides by 4x, by 1, by y. So we have negative 4x minus y minus 1. Okay. And then your dy dx becomes what? Your dy dx is, the negative can simply be factored out, no? So we have negative, and then we have here 4x plus y plus 1, then over x. So this is your dy dx from this expression.